There was a STEM contest that I had the pleasure of helping with that involved various drone operations using a provided DJI Mini2SE. One of the categories was a payload drop. Wait a second, the rule stated that the release system was open design, with no limitations, and it could be built or bought? There are plenty of independent drop systems on Amazon, but the reviews showed them to be unreliable, and I'm not one to do things the easy way. I faced several obstacles, mostly involving a limited time frame. Everything had to work the first time, as there was no time for redesigns. The Mini 2 is a small drone, so every component needed to be compact and lightweight. I wasn't sure how much it could carry, so I just kept everything as light as possible and hoped for the best. I didn't want to make any permanent alterations to the drone, and I didn't want to run a secondary transmitter and receiver. I knew an Arduino could control a servo, and the Nano was small enough to fit the design. I initially planned on using a photocell that could detect a light that could be toggled on the drone, but the SE model provided didn't have any auxiliary controls besides the camera gimbal. That meant the only path forward was to use the camera itself to trigger a microswitch. I found a CAD model of the Mini 2 and imported that into Fusion 360. I had a few scaling and performance issues, but once those were sorted out, the model was good to go. I wanted a saddle system that could be bolted on that would keep the major components balanced. I was concerned the saddle might block the GPS signal, but that was a risk I was willing to take. I also needed to leave room for the sensors on the bottom of the drone. The saddle was 3D printed and assembled with 632 screws. I discovered that the camera wasn't strong enough to trigger the microswitch, mostly because of the soft anti-vibration mounts. The whole gimbal would just move instead of pressing the switch, so it needed some leverage. I designed a long adjustable front arm to solve that. This was also my very first Arduino project. I already had basic programming and electronic skills, so I just needed to adapt to the Arduino coding and make it all work with the simple electronics. I couldn't find a servo control tutorial that matched what I was trying to do, so I pieced together information from several sources. It took a few attempts, and no, I didn't have AI write the code for me. At first, I built everything on a breadboard, then recreated it in Tinkercad when I learned it could be used for simulation. Along the way, I burned out an Arduino and a servo while experimenting. The biggest roadblock in servo control came from how I initially wired the microswitch. I had it toggling 5V on the signal pin. That caused a lot of noise and delay in servo movement. I eventually switched to grounding the signal pin and used an internal pull-up resistor. That solved all of the noise issues. I would have preferred using connectors instead of directly soldering components, but I didn't have the space and I worried about them coming loose. I know a 9V battery isn't ideal for powering an Arduino or a servo, and it's not great to power a servo off the 5V pin either, but due to space constraints I didn't have much choice. The rechargeable 9V that I found was lightweight, easy to recharge with a USB connection, and mounted nicely with some 3M automotive tape. The servo wasn't under heavy load or constant use. I also programmed it to move slower to reduce power draw. Looking back, a small 1S or 2S battery would probably have been a better power source, but this setup worked fine in this application. Unfortunately, the way I wired everything left no room for my top cover. It wasn't a big deal, I'll just call it a weight-saving feature. Only minor adjustments were needed to make everything work, and I figured those out as I went. The whole project was designed and built using the TLAR method. That looks about right, which I'm a big believer in as long as it doesn't put my life at too much risk. I had some trial and error with the payload container, but ended up going with a simple hinged box. I wanted something aerodynamic, like a small bomb shape, but couldn't make it both compact enough to avoid blocking the sensors and large enough to hold the payload. There were really only two operational obstacles. The first was it needed a platform to take off with the payload attached. Hand launching was too risky. So I used some scrap wood to build a launch platform. The second obstacle was the stabilized camera. It didn't always stay angled down the same amount during flight, which could accidentally trigger the release. Keeping the camera pointed down more than 45 degrees prevented that issue, and luckily the display shows the angle readout. In the end, the whole system worked perfectly at the competition and was by far the most advanced one there. Too bad there wasn't a category for design or engineering. This was a really fun project, and I can't wait to use more Arduinos in the future. There wasn't anything particularly difficult about this build, but it did require a pretty wide range of skills to pull off. If you want to build a project like this, just take it one step at a time, and remember, if I can do it, you can do it.